Hello and welcome to cosecant, secant, and cotangent, part 1. What we have here is standard form for looking at angles on the grid, or standard position. And you've seen this little triangle before, where we take a point that's on the terminal arm, and we say, well, the distance from the origin to this point is r. And that means if the coordinates of the point are x and y, then the length of this side of the triangle is x. Whoops, put some marks on there. And this side of the triangle is y. Now, we've defined in the past the sine of theta to be opposite, or y, over the hypotenuse r. Well, what we're now going to do is define a new trig function called cosecant of theta, and it's actually the reciprocal of sine. Instead of opposite over hypotenuse, it's hypotenuse over opposite. And that's pretty much all there is to it. I mean, it works kind of the same way as sine did, except it's the reciprocal of sine. Similarly, in the past, we've had cosine is the adjacent side over the hypotenuse, and secant of theta is the hypotenuse over the adjacent side. And then we had in the past tangent of theta is equal to opposite over adjacent, and the cotangent of theta is the reciprocal, which is adjacent side over opposite side. Okay, so you can see they're very similar, they're related, but they're the reciprocals. In fact, I'm going to show you a little trick here, because sometimes it's really tough to figure out cosecant if you don't have a cosecant button or a secant button or cotangent on your calculator. So how do you figure something out? Like, say we wanted to find out the cosecant of a certain angle. Well, the cosecant is the same as hypotenuse over opposite, but let's say I started off and did this. I'm going to prove to you that this works, that it is the same as 1 over the sine. So what I would do to prove this to you, well, what do we know of sine theta? Sine theta is y over r, so I have 1 over y over r. And to clean up this complex fraction, I would multiply the top and bottom by r. So here the r's would cancel, and we're left with r over y, which is in fact the same thing as cosecant of theta. So this is a really handy little trick. And of course, it's also going to be true for a relationship between cosine and secant, and tangent and cotangent. So it's a sneaky way of getting around calculator limitations. Let me just show you what I mean. Suppose you had to figure out something like, let's use secant this time. Secant of 20 degrees. You just want to figure that out, and you have no secant button on your calculator. So what we can do is go, well, that's the same as 1 over the cosine of 20 degrees. So now I just take my calculator, which I happen to have handy right here, and I'm going to punch in 1 divided by cosine of 20 degrees. And for that I get 1.064. Okay, so I'm just showing you that it's, even though you may not have these buttons on the calculator, the fact that they are reciprocal functions makes them very manageable. All right, let's clear off the screen and look at a couple more examples, and then that'll be it for part 1. So in this example, here's what we have. We have this point which is on the terminal arm. So on the terminal arm of theta. Terminal arm of theta. Okay, so we're given that information. And from that, we should be able to figure out what is the cosecant of theta, the secant, and even the cotangent, just as easily as we could figure out sine, cosine, and tangent. So how do we do this? Well, I'm going to first throw a little grid on the screen here. And gee, I don't know if we can we move this grid? We can. Perfect. All right, so there's my grid. And I'm going to draw this little point. So -3, so 3 to the left, and then up 5, 4, 5. So there's my point, which is, we're told, on the terminal arm. So let's just put a line down to the origin. Perfect. And what I'm going to do now is make my little triangle. Okay, my little right triangle. This side I think of as -3, and this side I think of as +5. If I use Pythagoras' theorem in this little triangle, I can figure out the hypotenuse. Okay, and we'll save you the trouble. I did this ahead of time, and I got the square root of 34 as my hypotenuse. Okay, so now if I use my reference angle, and I don't even have to worry about the cast rule here, because I've labeled this side as a negative side, so it's going to take care of itself. So I can just rattle off what is the cosecant. Now, I tend to use what I know so well, which is its reciprocal sign, and then I kind of flip it after that. So I basically look at this and say, well, the sine is 5 over root 34, so I'm going to flip it. So I'm going to go root 34 over 5. I just find it easier to start with something that I know so well. And it's positive, so I'm happy about that. By the way, the cast rule does work for all of these trig functions as well. You just got to remember that sine and its reciprocal cosecant are positive in this quadrant. Okay, you know, tangent and cotangent are positive in this quadrant, and in the fourth quadrant is cosine and its reciprocal secant. So cast rule does work. Anyway, back to what the question asked. Secant is, well, cosine would be -3 over root 34, so I just got to flip that and go root 34 over -3. I'm just going to call the whole thing negative. And finally, the cotangent of theta is, instead of 5 over -3, it's -3 over 5. So how easy is that? Okay, I'm going to do one last example before we leave this, short example. And this time we're going to do the following. We're going to find the exact value, so exact value of the secant of 330 degrees. Okay, so this time, now let's throw the grid up again. There's our grid. I'm going to draw 330 degrees. I'm going, well, okay, here's 90. Then I keep going. There's 180. Keep going. There's 270. So it takes me into this quadrant here. So I'm sort of like here somewhere. And if this here is 330 degrees for all of that stuff, then it tells me that my little reference angle here is 30 degrees. And if I think of this little triangle here, okay, that looks like one of my special triangles. And of course, when I read the word exact, I knew I was dealing with a special triangle. So let's just draw the special triangle. I'm going to orient it the same way as it is down here. So we've got 30, 60, and 90. The hypotenuse is 2. The shortest side across from the 30 degrees is 1, and then we had root 3 as the remaining side. So now I can go, well, secant of this 30 degrees would be the reciprocal of cosine. So instead of root 3 over 2, it's 2 over root 3. And then I got to decide, is it positive or not? Cast rule says cosine and its reciprocal stay positive, so guess what? Leave it as positive, and that's my answer. So that's where I'm going to stop for now. We'll come back with more stuff later.